I'm Brian.
I'm Josh O'Hara.
Okay, we're going to talk to you guys about our RGB LED controller.
Which is sort of inspired by, have any of you guys seen Philips Ambilight technology? Like the TVs, the big ones they have, whatever is on the screen, and it has lights around the outside of it, and it outputs whatever's on the screen, so it sort of projects on the wall to make it give you the effect that you're viewing a bigger screen than it actually is. So that's sort of what our goal was and sort of what it was taken from, where the idea came from.
Okay, so yeah, our requirements were we wanted to use pulse width modulation from the Nexus board. We had 3 output signals, one to control each color of the LEDs. Because I mean, I don't know if you guys are familiar with the RGB LEDs. It's basically like 3 LEDs in one, a red, green, and a blue. And by adjusting the brightness of each one, you can create a variety of colors. Like, I mean, just like mixing and matching. Like if you've ever done like Photoshop, how you have like the RGB sliders from 0 to 255, and you adjust the color that way. And we actually use pulse width modulation to turn on and off the LEDs faster than the human eye can see. So it's just like, you know, it's on for a certain amount of time, and the higher the LED cycle, the brighter the LED will be. So yeah, we also wanted to output the color to a computer screen using a VGA connector, and so yeah, that's
the basic requirements of it. And use a bunch of control switches. We have another set of 4 switches which sort of control, so you can manually set the color, either red, green, or blue. You can set each of those individually, or you can turn off that select bit, and then you can have up to 256 presets, like animations to be run on the LEDs. So say you want strobes or fades or different things to work with it, stuff like that. So that's the control lines.
Yeah, we only did like 10 or 15 presets.
Just to prove a point.
Because yeah, you guys get the idea. We probably don't have time to demo it all, but so this is the basic circuit diagram. Where you see these LEDs, there's actually 16, actually 32 in parallel where each of these are. But you know, this gives you the idea. Like if it were just
so this
one
is a single LED.
Yeah. So. The power supply right here is an external power supply, 5 volts, and these 3 signals are the pulse width modulated signals coming from the Nexus board. A couple problems we ran into designing was that we weren't getting a high enough voltage out of the Nexus board to either run the LEDs directly or even turn on and off the gate of the MOSFETs. So
these are at 4 volts. The gate voltage needs to be anywhere between 2 and 4. So if you have it on the upper end of the 4, then you're going to get your maximum amount of current with
yeah. Okay. So what we did instead was we used these external BJTs as like an amplifier basically, and they're connected to these pull-up resistors. So basically, when you get a low signal out of the pulse width modulated control signals, then that's going to turn off this BJT, and so there's going to be no current flowing through here, and the gate is going to be connected to VDD. And when you have a high signal out of there, it's going to turn this on and actually grounds the MOSFET.
It's all flipped.
So yeah, so an on, like a high from the controller actually turns off the LEDs.
We tried using our power supply from IMB 156, but our total project needs probably around about 2 amps to source the current to LEDs, so that power supply immediately just killed. Like as soon as we plugged it in, the LEDs just faded out. The power supply did something funny, so we ended up using an external computer power supply to source the current to it.
So yeah, that's hardware.
Okay, and then the software part of it is basically the base setup for the function generator lab, where you have the timer counters doing frequency generators. And instead of doing interrupts off of that, you use the PWM output of the timer so that you can enable get your 3 different RGB pulses out of it. And there's also an interrupt. There's a 4th counter that acts as the output frequency generator, which is pretty much how fast you want your LEDs to be outputting the colors that you're sending it. So it's anywhere from 30 hertz to 60 hertz and then 1000 hertz, just so you can see sort of the differences between them later. And then we also have an IP core that we created that uses the Influence external VHDL file that they supplied us, and then we sort of modified it a little bit so that it sends it all black RGB when it's on the blank portion of the screen, because that's wrap back around. That was one of the big problems I think everyone was having with the VGA display. So we did that and then linked it into microblaze and enabled it to send it an RGB value, and then the VHDL further processed it outside of the software part of it. And then we just had a couple of functions. The main function was gen PWM, which generates the specified PWM signal that we want for the specified colors. Set out the function I talked about, and then the pull function just pulls all of the switches and buttons. It does debouncing. It also acts as like an asynchronous interrupt, so that tells it when it needs to stop doing that certain preset and go on to something else. And all the LCD functions are the same as all the previous labs, and that's basically it for the software function. And then we weren't really sure what this slide was supposed to be for, but we can sort of talk about a little bit of the single LED. And
yeah, we did that like the first week after, after our last lab. We got the pulse width modulation for just like a red LED working, but one of the problems we ran into when we started using the RGB LEDs was that they're common anode instead of common cathode, so like, yeah.
And also the voltages were a bit different for the single LED, because we were able to drive the single LED with the Nexus board, but for RGB LEDs, because they're 20 milliamps per color, that's 60 milliamps per LED, like single LED, and there's just no way that the Nexus board was able to power all that.
16 per bar times 2 bars, so it's like...
It's a lot of current, and that's where we ran into problems. And sort of, after we had all the external circuitry, that was fine, and then we went to the task of trying to get VGA with it and just sort of mirror it. And it only does, we're kind of disappointed because the VGA only... I'm just going to start with, the screen should just mirror whatever the LED is, so that's the VGA green. And then there's one switch that controls the master on it, so if you set this switch, that means you're in set mode. So these 3 switches correspond to the, if you want to set the individual colors via the switches, so you get 8-bit color things. So this is all at 0, so if you want to start increasing it, the red will start going up, and then to the brightest one. So that would be the red. So the red is set, and then if you go back and reset the switches, you can set the blue to whatever you want. And the same with the green, so that would be the yellow. And then if you give the blue the same color, you can adjust however you like it. So that's the manual set mode. And then if you want to go back into preset mode, you just turn off the master control switch and it'll go back to default. And then the display, an extra feature was also the LCD, which displays the RGB value of the current thing, so it says 02550. And so the first preset is just all white. It turns all the LEDs on in the screen white, and it'll also display what the preset is right now. So that's the default. And then this one would be a fade to a red, so it's fading Roy G. Biv right now. And if you want to speed it up a little bit, we have buttons that actually increase the frequency of the output, so it'll go a little bit faster. There's 1500 hertz, there's 60 hertz, and then there's a slower 30 hertz, which it goes so slow. That's mainly for the strobing effect, so we'll keep it on the fast one for those. Then there's also a fade backwards, fades it backwards, and then there's a warm fade, which is just like a red, orange, yellow fade, and then a cool fade, which is a different one. So you can have a bunch of different presets and just program it in. And then starting with this one, I think it's the strobe. So this is a club strobe, which sort of goes on the screen, but the LEDs are actually outputting faster than the screen is able to. So if you slow it down, you'll be able to see it on the LEDs, but not the screen, due to the timings. So I mean, you could speed up your pulses too, and that's why we had this is at 30 hertz. So that LEDs can strobe, and that's like a blue strobe. And you could do a Cal Poly strobe, which is like yellow, green, and then go back to that one where you can do a blue strobe. A couple different ones, and again, the screen will actually keep up if you turn up the frequency. So that's basically it. Any questions? Yeah.